Lockheed SR-71 Blackbird. No reconnaissance aircraft in history has operated globally in more hostile airspace or with such complete impunity than the SR-71, the world's fastest jet-propelled aircraft. The Blackbird's performance and operational achievements placed it at the pinnacle of aviation technology developments during the Cold War. The Blackbird accrued about 2,800 hours of flight time during the 24 years of the active service with the U.S. Air Force. On its last flight, March 6, 1990, Lieutenant Colonel Ed Yeilding and Lieutenant Colonel Joseph Vida set a speed record by flying from Los Angeles to the Washington, D.C. in an hour, 4 minutes and 20 seconds, averaging 3,418 kilometers per hour. At the flight's conclusion, they landed at Washington Dulles International Airport and turned the airplane over to the Smithsonian. Hello guys, and welcome to our channel, Fighter Jets in Action. Please subscribe and like this video, and we love you for it. No reconnaissance aircraft in history has operated in most hostile airspace or with such complete impunity than the SR-71 Blackbird. It's the fastest aircraft propelled by air-breathing engines. The Blackbird's performance and operational achievements placed it at the pinnacle of aviation technology developments during the Cold War. The airplane was conceived when tensions with the communist Eastern Europe reached levels approaching a full-blown crisis in the mid-1950s. U.S. military commanders desperately needed accurate assessments of the Soviet worldwide military deployments, particularly near the Iron Curtain. Lockheed Aircraft Corporation's subsonic U-2 reconnaissance aircraft was an able platform, but the U.S. Air Force recognized that this relatively slow aircraft was already vulnerable to the Soviet interceptors. They also understood that the rapid development of the surface-to-air missile systems could put U-2 pilots at grave risk. The danger proved reality when a U-2 was shot down by a surface-to-air missile over the Soviet Union in 1960. Lockheed's first proposal for a new high-speed, high-altitude reconnaissance aircraft to be capable of avoiding interceptors and missiles centered on a design propelled by the liquid hydrogen. This proved to be impracticable because of the considerable fuel consumption. Lockheed then configured the design for the conventional fuels. This was feasible, and the Central Intelligence Agency, already flying the Lockheed U-2, issued a production contract for an aircraft designated the A-12. Lockheed's clandestine Skunk Works division designed the A-12 to cruise at Mach 3.2 and fly well about 18,288 meters. To meet these challenging requirements, Lockheed engineers overcame many daunting technical challenges. Flying more than 3 times the speed of sound generates 316 degrees centigrade temperatures on external aircraft surfaces, which are enough to melt conventional aluminum airframes. The design team chose to make the jet's external skin of the titanium alloy, to which shielded the internal aluminum airframe. 2 conventional but very powerful after-burning turbine engines propelled this remarkable aircraft. These power plants had to operate across a huge speed envelope in flight, from a takeoff speed of 334 kph, that is 207 miles per hour, to more than 3,540 kph, that becomes 2,200 miles per hour, to prevent supersonic shock waves from moving inside the engine intake causing flameouts. Johnson's team had to design a complex air intake and bypass system for the engines. Skunk Works engineers also optimized the A-12 cross-section design to exhibit a low radar profile. Lockheed hoped to achieve this by carefully shaping the airframe to reflect as little transmitted radar energy as possible, and by application of special paint designed to absorb rather than reflect those waves. This treatment became one of the first applications of the steel technology, but it never completely met the design goals. Test pilot Low Shalk flew the single-seat A-12 on April 24, 1962, After he became airborne accidentally during high-speed taxi trials, the airplane showed great promise, but it needed considerable technical refinement before the CIA could fly the first operational sortie on May 31, 1967, a surveillance flight over the North Vietnam. A-12s, flown by the CIA pilots, operated as part of the Air Force's 1129th Special Activities Squadron under the Accrued program. While Lockheed continued to refine the A-12, the U.S. Air Force ordered an interceptor version of the aircraft designated the YF-12A. The Skunk Works, however, proposed a specific mission version configured to conduct post-nuclear strike reconnaissance. This system evolved into the USAF's familiar SR-71. Lockheed built 15 A-12s, including a special two-seater trainer version. 2 A-12s were modified to carry a special reconnaissance drone, designated D-21. The modified A-12s were redesignated M-21s. These were designed to take off the D-21 drone, powered by a Mach-quart ramjet engine mounted in a pylon between the rotors. The M21 then hauled the drone aloft and launched it at the speeds high enough to ignite the drone's ramjet motor. Lockheed also built 3 YF-12As, but this type never went into production. 2 of the YF-12As crashed during testing. Only one survives and is on display at the USAF Museum in Dayton, Ohio. The aft section of one of the written-off YF-12As, which was later used along with the SR-71A static test airframe to manufacture the sole SR-71C trainer. One SR-71 was lent to NASA and designated YF-12C, including the SR-71C and 2 SR-71B pilot trainers. Lockheed constructed 32 Blackbirds. The first SR-71 flew on December 22, 1964. Because of extreme operational costs, military strategists decided that the more capable USAF SR-71 should replace the CIA's A-12s. These were retired in 1968 after only 1 year of the operational missions, mostly over Southeast Asia. The Air Force's 1st Strategic Reconnaissance Squadron, part of the 9th Strategic Reconnaissance Wing, took over the missions, flying the SR-71 beginning in the spring of 1968. After the Air Force began to operate the SR-71, it acquired the official name Blackbird for the special black paint that covered the airplane. This paint was formulated to absorb radar signals, to radiate some of the tremendous airframe heat generated by air friction, and to camouflage the aircraft against the dark sky at high altitudes. Experience gained from the A-12 program convinced the Air Force that flying the SR-71 safely required 2 crew members, a pilot and a reconnaissance system officer. The RSO operated with a wide array of monitoring and defensive systems installed on the airplane. This equipment included a sophisticated electronic countermeasures, that is ECM system, that could jam most acquisition and targeting radar. In addition to an array of advanced, high-resolution cameras, the aircraft could also carry equipment designed to record the strength, frequency, and wavelength of the signals emitted by the communications and sensor devices such as radar. The SR-71 was designed to fly deep into the hostile territory, avoiding interception with its tremendous speed and high altitude. It could operate safely at a maximum speed of Mach 3.3 at an altitude more than 16 miles, or 25,908 meters above the Earth. The crew had to wear pressure suits, similar to those worn by the astronauts. These suits were required to protect the crew in the event of the sudden cabin pressure loss while at operating altitudes. To climb and cruise at the supersonic speeds, the Blackbird's Pratt & Whitney J58 engines were designed to operate continuously in the afterburner. While this would appear to dictate high fuel flows, the Blackbird actually achieved its best gas mileage in terms of aeronautical miles per pound of the fuel burn, during the match 3+ cruise. A typical Blackbird reconnaissance flight might require several area refueling operations from an airborne tanker. Each time the SR-71 refueled, the crew had to descend to the tanker's altitude, usually about 6,000 meters to 9,000 meters, and slow the airplane to subsonic speeds. As velocity decreased, so did frictional heat. This cooling effect caused the aircraft skin panel to shrink considerably, and those covering the fuel tanks contracted so much that fuel leaked, forming a distinctive vapor trail as the tanker topped off the Blackbird. As soon as the tanks were filled, the jet's crew disconnected from the tanker, relit the afterburners, and again climbed to high altitude. Air Force pilots flew the SR-71 from the Kadena AB, Japan, throughout its operational career, but other bases hosted Blackbird operations too. The 9th SRW occasionally deployed from Beale's AFB, California, to other locations to carry out operational missions. Cuban missions were flown directly from Beale's. The SR-71 did not begin to operate in Europe until 1974, and then only temporarily. In 1982, when the U.S. Air Force based 2 aircraft at the Royal Air Force Base, Mildenhall, to fly monitoring mission in Eastern Europe. When the SR-71 became operational, orbiting reconnaissance satellites had already replaced manned aircraft to gather intelligence from the sites deep within the Soviet territory. Satellites could not cover every geopolitical hotspot, so the Blackbird remained a vital tool for global intelligence gathering. On many occasions, pilots and RSOs flying the SR-71 provided information that proved vital in formulating successful U.S. foreign policy. Blackbird crews provided important intelligence about the 1973 Yom Kippur War, the Israel invasion of the Lebanon and its aftermath, and pre- and post-strike imagery of the 1986 raid conducted by the American Air Forces on Libya. In 1987, Kadena-based SR-71 crews flew a number of missions over the Persian Gulf, revealing Iranian Silkworm missile batteries that threatened commercial shipping and American escort vessels. As the performance of space-based surveillance system grew, along with the effectiveness of the ground-based air defense networks, the Air Force started to lose enthusiasm for the expensive program, and the 9th SRW ceased SR-71 operations in January 1990. Despite protests by military leaders, Congress revived the program in 1995. Continued wrangling over operating budgets, however, soon led to final termination. The National Aeronautics and Space Administration retained the 2 SR-71As and the 1 SR-71B for high-speed research projects and flew these airplanes until 1999. On March 6, 1990, the service carrier of one Lockheed SR-71A Blackbird ended with a record-setting flight. This special airplane bore Air Force serial number 617972. Lieutenant Colonel Ed Yeilding and his RSO, Lieutenant Colonel Joseph Vida, flew this aircraft from Los Angeles to Washington, D.C. in 1 hour, 4 minutes and 20 seconds, averaging a speed of 3,418 kph. That becomes 2,124 miles per hour. At the conclusion of the flight, 972 landed at Dulles International Airport and taxied into the custody of the Smithsonian's National Air and Space Museum. At the time, Lieutenant Colonel Vida had lodged 1,392.7 hours of flight time in the Blackbirds, more than that of any other crewman. This particular SR-71 was also flown by the Tom Ellison, a former National Air and Space Museum Chief of the Collections Management. Flying with the Detachment 1 at Kadena Air Force Base, Ellison lodged more than a dozen 972 operation stories. The aircraft spent 24 years in active Air Force service and accrued a total of 2,801.1 hours of flight time. Well, that's it guys for today. I hope you liked this video and subscribe to our channel and hit the bell icon for the most recent updates on fighter planes.